versus detergent.
In our experiment, we tested the effects of biodegradable and conventional detergents on the ecosystem. Our hypothesis was that the mean number of alive worms in the biodegradable detergent would equal the mean number of alive worms in the conventional detergent after 1 week. The alternative hypothesis is the mean number of alive worms in the biodegradable detergent would be greater than the mean number of alive worms in the conventional detergent after 1 week.
The materials we needed for the experiment were styrofoam cups, night crawlers, about 90 worms, plotting soil, permanent markers, liquid laundry detergent, 1 biodegradable and 1 conventional, tinfoil, water, plastic spoons, scissors, a kitchen scale, a liquid measuring cup, a 5 milliliter measuring spoon, toothpicks, a lab notebook and pen, newspaper, a large work area, and a small refrigerator space.
The methods for our experiment are: Step 1, acquire a large work area. Step 2, gather materials that were mentioned before. Step 3, label styrofoam cups with the name of the conventional liquid detergents and the concentration as follows. Control 50% Pure X, 100% Pure X. Step 4, repeat Step 3 with biodegradable laundry detergents. Step 5, thoroughly mix the detergent solutions before diluting them in the steps outlined below. Pour one of the detergents into the labeled styrofoam cup and mix it by stirring with a clean plastic spoon. Avoid forming bubbles. A, in the cup labeled 100% and 200 milliliters of liquid detergent. B, in the cup labeled 50%, add 100 milliliters of liquid detergent and 100 milliliters of water. C, in the cup labeled 0%, add 200 milliliters of water. D, cover the cups with tinfoil to avoid evaporation. E, repeat 1 through 4 with clean materials to create the dilution series for each detergent. Exposing worms to the detergents. Step 6, using a toothpick, poke several holes in the bottom of the 3 empty styrofoam cups. Step 7, label the cups with the name of the detergent, the date, and the percent of detergent solutions as follows. A, control. B, Pure X, date 50%. C, Pure X, date 100%.
Step 8. Add 100 grams of potting soil to each cup. Use the kitchen scale to measure 100 grams. Step 9. Add 5 milliliters of liquid from the dilution series to the appropriate cup. Step 10. Mix the detergent into the soil with a clean spoon. Step 11. Randomly assign 6 worms to each cup by using the random number generator in your calculator. Produce the numbers 0 and 1 30 times, then each worm selected from the box will be assigned a 0, which is the 50% solution, or a 1, the 100% solution. The first 6 ones chosen will be placed in the biodegradable 50% solution, and the last 6 ones chosen will be placed in the conventional 50% solution cups. Same goes for the zeros. Once all the treatment cups have been filled, place the last 6 worms in the control cups. Step 12. Cover the cups with aluminum foil. Poke several holes into the tinfoil with a toothpick, and store them in a refrigerator away from direct sunlight or hot air from a heater vent. Step 13. Repeat steps 6 through 12 for the additional detergent. You should have 5 cups with worms in them when this section is completed, 1 for each of the 4 detergent solutions and 1 control. For more accurate results, repeat the process a total of 3 times. 15 cups total, 6 per detergent, 3 per percent solution. Counting worms. Count the number of live worms every other day. Step 14. Group the cups together by type, biodegradable and conventional. Step 15. Group together the percent solutions within each type.
Step 16, gather materials. Step 17, lay out newspaper for the counting and gather solution mixtures. Step 18, start the counting from ascending order by the percentage. Control 50%, 100%. Step 19, start with 1 soil cup. Take off tinfoil and pour cup onto newspaper. Label sticky note, date, detergent name, and percent. Put sticky note by the soil and worms. Take picture with camera. Step 20. Separate the live worms and dead worms. Use same label sticky note as before. Place it with the worms and take a picture. Step 21. Count how many are live and dead from each cup and record into logbook. Place dead worms into a styrofoam cup. Step 22. Pour soil into a mixing cup. Step 23. Mix in 5 milliliters of the same solution as the labeled soil cup into the soil. Mix with a clean spoon. Step 24. Mix live worms back into the soil and place the tinfoil back on top. Step 25. Repeat steps 19 through 23 with all the cups. After all counting, place all cups back into the refrigerator. Place in different
At the
spots
conclusion
after
of the
every
experiment, we counted the number of live worms. In the control group, in all cups, 6 worms were left. In the 50% biodegradable cup, no worms survived. In the 100% biodegradable cup, no worms survived. In the 50% conventional cups, no worms survived. In the 100% conventional cups, no worms survived.
After this science experiment, we have sufficient evidence that biodegradable detergents are just as harmful to the environment as conventional detergents. According to the collected data, the null hypothesis was proven to be correct.
Therefore, we can fail to reject that the mean number of live worms in the biodegradable detergent equals the mean number of live worms in the conventional detergent after 1 week.